50.05 grams of calcium carbonate decomposes into calcium oxide and carbon dioxide. If we get 20.05 grams of carbon dioxide from the experiment, what is the percentage yield of the reaction? So before we begin answering the question, let's first create the equation for the reaction, since in stoichiometry, creating the equation before you even begin answering it is really important. So we get 1 mole of calcium carbonate breaks apart into 1 mole of calcium oxide and 1 mole of carbon dioxide. So for percentage yield, there's quite a few terms that we have to know and one formula that we need to know how to use. So our first definition is for experimental yield, which is the value that we get from an experiment. And usually in a question about percentage yield, it is the value that we are given. So let's look at the question. So we know that we did an experiment with 50.05 grams of calcium carbonate, and we know that we got from the experiment 20.05 grams of carbon dioxide. So we can say that the experimental yield for carbon dioxide is 20.05 grams. Yield is just what we get after the experiment. So after the experiment, we get 20.05 grams of carbon dioxide. Then we have theoretical yield, where theoretical yield is a literature value or the value that is in theory. So theoretical yield, for example, would be the value that we would get from doing mathematical processes on the equation that we've been given. So the reason for why we have an experimental yield and a theoretical yield, the reason why they're not the same is because an experiment or a reaction can never be perfect. So if we do an experiment, there's going to be many mistakes that prevent us from getting the perfect value, the value that we would get from doing mathematical processes. So we usually say that the experimental yield is smaller than the theoretical yield because we can never reach the perfect value or we can never exceed it. So the formula for percentage yield is the experimental yield over the theoretical yield, which would give us a decimal, times 100%, which would then give us a percentage value. So let's apply this to the context of our question. So we've been given 50.05 grams of calcium carbonate. So the mass for calcium carbonate is 50.05 grams. And somehow to calculate the percentage yield, we need to find the theoretical yield because only then we can apply the formula for percentage yield. So we've been given the experimental yield, and to find the value that it was supposed to reach, we will need to use stoichiometry. So if we have the mass of calcium carbonate, we can find the number of moles of it. So the number of moles of calcium carbonate would be mass over molar mass, which is 50.05 over 100.09, which is 0.9, which is roughly 0.5 moles. So looking from the equation, we know that the number of moles of calcium carbonate is equal to the number of moles of carbon dioxide, which is equal to 0.5. So if we rearrange the equation, we can get that the mass of carbon dioxide would be equal to the number of moles times its molar mass, which is 44.01, which gives us roughly 22.01 grams. Okay, so now we have the experimental yield, which is from the question, and now we have a theoretical yield. So now we can easily apply the formula for percentage yield to find the percentage yield. So the percentage yield would equal to the experimental yield, which was 20.05, over the theoretical yield, which is 22.01, times 100%, which is roughly equal to 91.09%. So yeah, as we said before, the percentage yield can never be greater than 100%, and it can never be exactly 100% because our experiment can never be perfect. So that's how you find the percentage yield for a reaction.